Hey, assalamu alaikum. Welcome to the YouTube channel Advanced Learning Machine. Now we shall discuss about data handling, decision the tree induction. In decision tree induction, many algorithm, Hunt's algorithm, CART, ID3C4.5, Sleek Sprint, we shall discuss about these things. In journal structure of Hunt's algorithm, let dt be the set of the training record that reach a node T. Journal procedure: if dt contains record that belongs to the same class, then T is a leaf node labeled as yt, and the same as below. Like if dt is an empty set, then T is a leaf node labeled by the default class yt. If dt contains record that belongs to more than one class, use an attribute test to split the data into smaller subsets. Recursively apply the procedure to each subset. Here you can see the Hunt's algorithm. Don't cheat, refund yes or no. In refund, don't cheat Marshall status, and in which the second hand we shall discuss about the Marshall status taxable income. When we shall discuss about the similarity and dissimilarity, in similarity numerical measures of how alike two data objects are is higher when objects are more alike, often falls in our range. In dissimilarity numerical measure of how different are two data objects, lower when objects are more alike, minimum dissimilarity is often 0. Similarity and dissimilarity for simple attributes. P and Q are the attribute values for the two data objects. In attribute type, nominal and ordinal, interval or ratio. In dissimilarity column, D is equal to 0, 1, values mapped to two integers where n is the number of values, and in similarity, the numeric values are given. In Euclidean distance, Euclidean distance, this is equal to, there are the formulas here, where n is the number of dimension attribute and pk and qk are respectively the kth attribute components of data object p and q. Standardization is necessary if scales different. In Euclidean distance, you can see here the graph which is drawn in 2 point P1 and in 2 on x-axis P2, and in 3 above the P2 there is P3, and on the x-axis there is the 5 on P4. Now here's a point 1, point 2, point 3, point 4 in which x or y denoted. In Minkowski distance, Minkowski distance is a generalization of Euclidean distance where r is a parameter, n is the number of dimension attribute, and pk and qk respectively the kth attribute, or the data objects p and q components. Now we will discuss about the common properties of a distance. Distance such as the Euclidean distance have some well-known properties like dpq greater than 0 for all p and q, and dpq is equal to 0 only if p is equal to q, positive definiteness. Where dpq is a distance dissimilarity between points data object p and q. Here is some data which shows the positive definiteness, and there is some other data that is known that shows the symmetry. Now when we shall discuss about the common properties of similarities, similarities also have some well-known properties like SPQ is equal to 1 for maximum similarity only if P is equal to Q. In the second option, SPQ is equal to SQP for all P and Q, that is the symmetry. Where SPQ is a similarity between the points data object P and Q, in which we shall discuss about the symmetry and maximum similarity, which is called the definiteness. In the previous slide we have discussed something that is very important. So here is a similarity, there is a common properties of the similarity which have discussed, that the symmetry and the definiteness which is in the point 1 and symmetry in the point 2. Between these 2 points with the similarities which is between the P and the Q. Now we shall end our lecture here. Thank you for all to stay tuned with us. If you like the video, then kindly subscribe and share. We will come up with our next video in our next lecture. Thank you. Stay blessed. Allah Hafiz.